Good morning, everyone. So we will start the first panel discussion for today's workshop. And it's my pleasure to be the coordinator of the first panel. And in this panel, we will have three distinct guests. And let me introduce them before we start the discussion. So the first panelist will be the Professor Yongjin. He's the Vice President of the Korean Math Societies and the Chairman of the Korean Mathematics Olympiad Committee. His research includes the category theory, homotopy theories, loop space structure, wave groups, mapping class group. Professor Yongjin graduated from Seoul National University in 1981 before achieving PhD degree in mathematics at the Ohio State University. Since 2000, he has been the professor in Inha University. He is the chairman of the Korean committees, the chairman of the program committee of the Korean Math Olympiad, and he has been the leader of the Korean team for more than 20 years. So it's a great honor for us to have him today to say about the experience of Math Olympiad in Korea. The second panelist is Professor Po-Shen. He's an American professor in mathematics at the CMU and the national coach for the United States International Math Olympiad for many years. Under his coaching, the US team won the competition in 2015, 16, 18, and 19, right? I mean, it's a big achievement for team. I think US got four-time, absolute winner in the last 10 years. He had previously won the silver medal for the US as a participant in 1999. Professor Law ran the popular course to train students for the put-down competition, and is the founder of XP. He also teaches course on discrete math and extremal combinatorics at the CMU. He's graduated with honor from Caltech in 2004, then go to Cambridge to get his master's degree in 2005 and get a PhD in Princeton in 2010. So it's also a great honor for us to have Po-Shen today to share about the experience of the US. And the first panelist is the Dr. Han Kim Ho. He's the Vice President of the Singapore Mathematical Societies. He has a Master of Science in Statistics, Master of Education in Math Education, and a PhD in Pure Math. He's a lifetime member of the Singapore Math Societies and has been the Vice President from 1994. He oversees the identification and nurturing of the mathematical talents in Singapore. He was among the few people who started the Singapore Mathematical Olympiad in 1995. He was also involved in the training of the Singapore International Math Olympiad teams from 1989 to 1994, and has been the deputy chairman of the Singapore Mathematics Olympiad Committee since 1995. Dr. Han is currently the principal of the junior college and continues to advise a number of network learning circles of mathematics educators across the country, as well as contribute to the development of the science education and research through judging of the STEM research projects at the national competition as a member of the Research Institutional Review Board in Singapore. It's a great honor for us to have you today, sharing about Singapore. So we have three distinguished guests, and I'm pretty sure that many participants are very excited to learn about experience from your country. So may I start with Professor Yongjin about the Korean experience. In the IMO, I think Korea started joining the IMO in 1988, right? And it's one of the strongest teams. So, Professor Yongjin, can you start?
Okay, may I share? Right, is shared?
Yeah, we can see those.
Yes, let me briefly introduce the Korean Math Olympiad, maybe in 10 minutes. So education, first of all, education system of South Korea. We have a 52 million population, and about 30% of the whole population live in Seoul area. And school system is we have 6 years in primary school and 3 years in middle school and 3 years in high school. And education is a very big social issue, maybe next to economy. And students are very competitive. I mean, to enter good universities. And we participated in IMO in 1988 for the first time, and since 2011 we belong to the best 4 or 5 countries. So since 2012, Korean team has been in the same level as the best teams like United States and China and Russia. And in IMO, the ranks are like this. And in 2009, 19, and 20 and 21, we were in the third rank in a row, 3 years in a row. And also, I like to mention Asian Pacific Math Olympiad, APMO, because APMO, I think APMO is a very good event to compare the level of participating countries. I'm sorry that Vietnamese team has not been participating in this event. The reason, okay, the APMO is held in March. About 40 countries are participating in this event. And usually in APMO, we have the students have 4 hours for testing, and then 5 problems are given. And the reason why APMO is very good event is that very good reason is that usually many students are participating. About 40 to 50 students take the exam, and only the top scores are counted. So it's very good event to compare the levels of participating countries. So APMO results from 2014 to 18, and we are like this. Usually Korea and United States and Russia are stronger than others, and also Singapore is very strong. But if Vietnamese team participate in this event, maybe they belong to top 2 or 3, I think. And the Korean Math Olympiad. Korean Math Olympiad is organized by Korean Math Olympiad the committee, and also it belongs to Korean Math Society. And and then I myself participate in IMO as a team leader or deputy leader for 24 times. And usually in domestic Olympiad, we have 3 rounds: first round, second round, and we call final round. We call FKMO. And the KMO budget consists of 2 incomes, and one is government support, about $200,000 US, and the second one is exam fees. It's about $300,000 US per year. And we have, first of all, KMO, the first round. Usually in May, we have a first round, and we have 2 categories in high school and 1 category in middle school. And we have 2 categories. One is Gauss. I named it. One group is Gauss, another group is Euler. Gauss is for only science high school students. The Euler group is for ordinary high school students. So usually it's 5 hours and 220 problems. The second round is only November. There are only 2 categories, high school and middle school. And 8 problems and 6 hours. And 3 hours in the morning and 3 hours in the afternoon. The difficulty of KMO 2, the second round, is similar to maybe APMO or FKMO, actually. So FKMO is late March usually, and 6 problems, 9 hours, same as IMO. In the first round, it's like this a little complicated, so I'm going to skip it. The basic problem on the first round is that we have less students than before participating in the event. And then you have in the first round, usually we have a regional award and also national award, 2 different awards. And answers are of 3-digit numbers. So you just mark the answers on computer cards. And Camo 2, as I mentioned, 8 problems, 6 hours. But yeah, and yeah, actually this KMO2 is the main round. So only on KMO2 we have like gold medal, silver medal, and bronze medal, and then those medals are counted by schools when they enter the university or high schools. Okay. This is the main issue, the last one. Department of Education of the Korean government about 10 years ago ordered universities not to count KMO medals in admitting their new students because they believe that the Olympiad is a good reason for private lessons. I mean, so the Department of Education wants to reduce the private lecturings like that. And final round is quite similar to IMO, only high school level, and no medals are given. And usually we give like honorable mentions to top 30 to 40 students. Okay, so usually high school students are very busy for preparing for entering universities. So their school records are very important to enter the universities, but Korean Math Olympiad medals are not counted in entering universities. So they have very little time to prepare for a final round. So that's the basic problem of the Korean team. A number of participants in KMO 1 and 2. Here, every year the number of participants are similar, but until like 10 years ago, before the Department of Education decided to decide not to count KMO medals in entering universities, the number sharply decreased. Number of participants sharply decreased. I mean, like maybe about 20 or 30% of 10 years ago. So the number of participants are decreasing every year, and actually this year the participants of KMO 1 decreased a little. Okay, education program for KMO, we have a summer camp and winter camp. Usually it's about 2 weeks every event, and usually in August and January. And usually we accept 30 middle school students and about 70 high school students. And yeah, so we have also the winter camp exams and summer camp exams. And the scores of winter camp is counted to be selected in for IMO contestants. And every day we have a very busy schedule, two 90-minute lectures and 4 recitation classes. And even after the lectures, the students are gathering and discuss about the problems and what they learned on that day and things like that. And also we have very good assistants. Usually we have about 10 assistants who are former IMO contestants, and they are usually college students. And the second education program is male education in spring and autumn. Usually it's about 7 or 8 weeks in autumn and spring. Yes. And every week we have give students about some contents 8 to 100 pages of materials to study. And also we give them 3 problems to solve. And then students are supposed to solve the problems and submit the solutions by mail, the usual mail. And also we have weekend education program. This is only for IMO contestants and on some other very young best students. So usually about 15 students are participating in weekend education programs just before IMO. So it means May and June for 7 or 8 weeks every year. And also we have intensive education program, and this is a quite unique program for our team. Just before participating in IMO, we have usually about one month of intensive education program. That means intensive means every day 8 hours. Yeah, so usually no lectures, but students are solving their problems, and in the afternoon they discuss about the problems, what they solve and not solve, and things like that. So this is the most important program for IMO contestants. So in this 1 month of intensive education programs, students are getting stronger so much. Okay, and selection of IMO contestants, we count 5 exam scores, and also at the final stage we have a final TST. And this is also a very unique part. I announced in 2016. Then we call it final candidates. If one female students belong to top 12 to 15 students, which is called the group. This group is called a final candidate, and then that female students can participate in IMO automatically. So because of this rule, we have two female students so far, and she got 2 gold medals in IMO. And we have also unique systems, high school systems. We have 28 science high schools and 20 ordinary science high school and 8 specific science high schools, which is called science academies. We have about 1636 new students every year, and yes, and also, but out of 28 science high schools, the Seoul Science Academy is supposed to be the best. So all students stay at dormitories. So there are some differences between science high school and science academy, but okay, I don't have much time, so I skip it. And education system for the gifted. We have a very good rules and laws and for education systems for the gifted. So besides science high schools, we have 27 science education centers. That is mainly for 6th to 7th and 8th grade students. So very young students, and we have about 5,500 students in the whole. And we have some bright sides and dark side. So I could have some more time to discuss about it, but so one very important bright side is that we have a very good group of very young, talented students, like 11 or 12 years old. And then also we have a good group of assistants who are mainly college students and former IMO contestants, and helping the professors in educations like summer school and winter school. And dark side is that Department of Education is suppressing the math and science Olympiads. because they believe that it causes a lot of private lessons problems. And so the result is that number of students are decreasing, also number of female students are decreasing. And also too much concentration on one high school, which is Seoul Science High School. And this is my personal view. For the best students out of 1 million students, the talent itself is not so important, because I think 0.1% of gift is sufficient, but more important factor is that their character and also circumstances. That's my personal point of view. Okay, I'm gonna finish it now. Thank you.
Yeah, thank you, Professor Yongjin. It's a very informative presentation, and I'm pretty sure there will be many questions from the participants wanting to clarify some points and the training system in Korea. Now we wrap the same for Professor Po-Shen. Can you share with us about the, how in US you can identify the young talents and nurturing them?
Yes, absolutely. Hello, everybody. I will be speaking, and I hope that the language is understandable. If you want me to speak slower or faster, either way is okay. But my talk is going to focus on not only the very, very top students, but actually more students. In fact, I was inspired by the great work that Yongjin and Song and his team in Korea did, because I tell you this story. So people used to ask me why the United States always loses to China at the International Math Olympiad. This was when I was the deputy leader, the second person in charge. And I always said, well, of course, China has 4 times as many people as United States. So because of numbers, because of statistics, of course, China will beat US. But then in 2012, it was South Korea that won. And when I was explaining to other people, well, it's because South Korea has 4 times as many people as US. That's not true. So then I started to think, what is the relevant factor? And it was really, I never mentioned this to Professor Song, but this is what caused me to realize that what is relevant is not the population of the country, but the population of students in the country who decided that they wanted to work hard on that subject. And it so happens that in South Korea, you have lots of people, especially compared to United States. The number of people in South Korea who care very much about studying mathematics, studying in general, is actually very high. And so when I eventually became the coach of the US team, I decided that what I wanted to do was to just increase that basic number of students who are interested in doing mathematics and mathematics competitions. Notice I didn't say gifted. I actually am of the opinion that there are many people who can become very good at mathematics. And it is not because they were born with a gift. It is something to do with how you are learning and what kind of environment that you are in. And there are plenty of students who, if they go in the right way of learning, they might suddenly look gifted. So I decided I wanted to work on having more students be strong. Actually, also, when I became the national coach of the team, I'm a very strange person. I had a discussion with the organization which is in charge, called the Mathematical Association of America. And in that conversation, I said, if you make me the coach, USA will do worse, because I'm not going to focus on whether the team wins. Actually, what I care more about is that the US students who I have the chance to work with, eventually in 20 years, go and achieve something that we read about in the New York Times. That's what I said. That's the goal. And however we do on math competition, we'll see. I don't know. So yes, we did well on the math competitions, but that was actually not the goal. But I say all of this because I want to emphasize that the context that I work on with this gifted education is that the goal is to have people from all over succeed, and also that their success has longer term than winning competitions. With that, I'm going to show a few pictures. Now, the way that I actually share my screen is that I just change my background. So the way to see me, I will do this spotlight here. So my picture should now be big for everybody. If you cannot see my picture big, just right-click on my picture and press pin video, because that's how I'll do the rest of this talk. Here I put a map, and I put this map every time I talk about the talent in the United States, because the US is large, and sometimes people think that all of the talent might come from San Francisco, or Los Angeles, or Washington, DC, or Boston, or New York City. Well, this map has 6 points on it. The reason it has 6 points is because the International Math Olympiad team has 6 people. And this was where those people were from in the year that the US ranked #1 while I was a coach. This was 2015. And the important thing about this map is that there's nothing in California. Actually, if you look at where these people are from, many people have not heard of these cities. This city is in Kansas. This city is St. Louis, Missouri. This city here is in South Carolina. We have one person from New York, but if you know American geography, this is not New York City. This is a city called Rochester, New York. Not big city. And then we have 2 from around New York or New Jersey. But why I show this is because this is showing how in the US, the people who go all the way to the top actually come from very strange places. I've had many conversations with those students, and there's a pattern, because I myself was also on the team. I came from Wisconsin. I was from here. And there's a pattern where there are many students who do very well in US who come from strange places. And the pattern is that many of them are done with their school homework by 4:00 p.m. I was the same. By 4:00 p.m. every day, done, no more schoolwork. Now what do? Now you can do interesting things. So if you're talking about advanced students or gifted students, I don't like to use the word gifted because I like to think that anyone can pick up that ability. But when you think about these students, actually what you want is you want to make sure that they have the freedom to go and push themselves into more, to learn more. So that is one interesting point that I want to make from here. It's also because of the fact that United States is a big country that one of the things we try to do is to try to get many people interested. I personally, as the coach of the US team, spend less of my time teaching the top students than I do running around the country. Here's what I did this summer. In the months of July and August, I went on a trip because the United States had less COVID of this pandemic. The COVID became better by the end of June. And so since our US National Math Olympiad program, camp, had finished at June 25th, I was free. And starting from June 28th, I went on a big trip. These are all the places where I gave talks between June 28th and August 12th. There are 40 cities here because the goal was to go coast to coast, as well as some places in the middle. Every place, give talk, hopefully, every place on average about 100 students. Because the goal was, if you want to have success throughout the whole country, then you go to all the places, including places that you may never have heard of before from these parts of the middle of the United States. But why I think this is important is that when we did this, when I was planning this trip, the method was to choose all of the cities which have at least 500,000 people in them. I didn't get to all of them in the summer. I'm still moving around on this tour. But the concept was, if a city has at least 500,000 people who live in it, there's talent there. And this is what I've noticed. I'm saying this because I see that the audience for this talk is not only coaches of top students, but also teachers. And I think people who care about all of the well-being of the country. And so this is one way to scatter all across the country. I'm not the only person who does this. In fact, there are other sources that cause all over the US there to be energy that moves people towards competitions. going back to this picture, I'll share, this is just a photo from a bus. I guess I'm in the photo right here, but this is from before COVID. Before COVID, there were these math competitions that were all around the United States that people would get on buses to go to the contest. And it was wonderful. This is a group of students from Virginia, and they were all going on bus to some mathematics competition. But you can see from the smiles on the face and the excitement that what we have always been doing is we've been trying to make it so that the competitions become a social activity and a chance for people to meet each other. This is actually the site of where that bus was going. This is a stadium. And what we did, this is a stadium for what? For hockey, the sport where you hit like this. And what we did is we have the stadium and people go into the stadium to do math competition. They are actually not trying to win. Why they all come is because they want to see each other. Because in America, it's funny. If you want to do math competition, it is not only because of getting into university, because many universities need more than math competition. They ask many questions on the application. And so actually what we do is we try to make it so that the students who want to push themselves can find other people around them who like to push themselves. And maybe not so many in one school, but if you make many kinds of events that bring people together from far away, then they meet each other and continue talking on internet. A few more random things I want to talk about. I also, in what we do, in training the US team, for example, we try to teach people concepts that are not even on Olympiads, because the goal was what happens eventually. So, for example, this is a picture of a die. We teach probability. Probability is not a subject that's on competitions, but on the other hand, probabilistic method was actually one of the great innovations of a famous mathematician named Paul Erdős. And Paul Erdős is a pioneer of many techniques in the last century. Probabilistic method in combinatorics is actually my own area of research. And we would teach people concepts from this at the National Math Olympiad training camp. Actually, while I talk about National Math Olympiad, now I will switch gears and say, what do we actually do when we find the people who are at the top? Of course, we have contests. We have many contests that can go and find people at the top. But when you finally get to the top, you come to Carnegie Mellon University, that's where I'm based, and we then have you learn mathematics in all kinds of different places. Actually, this talk is in a lounge. This is just a place with sofas, and the person who's talking is talking about quantum computing algorithms. That's actually where this talk is. This is quantum computing algorithms. The speaker is a student. He's not a high school student. He's a university student. And he was talking, actually, maybe he was a graduate student by then, but he was talking about quantum algorithms, because what we do is, yes, we teach people the mathematics, but then for a lot of the time, we also will just talk about what the actual people are doing now. For example, what I do also is I will also talk about what I do. And these days, what I do is not even normal mathematics. The most recent things that I work on are in fact about public health. Actually, now I overlapped with our colleagues in Singapore, because somehow with the thing that I work on, I even messaged their prime minister because of the work that we are doing using mathematics to go and fight disease. But so what the purpose of this, by the way, is we want to take these students and we want to inspire as many as possible to decide that they want to work harder. Then we want to let them meet other students so they make friends, and then they want to work harder. And finally, by the time they get here, then the message we tell them is that you have a job now. You didn't win something, you won a responsibility. You now have a job. Your job is to go and help to save the world. If you don't do it, who will do it? And then we expose them to all the things that these various trainers are doing now. One other thing that I'll end with about what we do, we don't think of this as US-centric either. It's not America-centric. We actually see this as something which can help to create innovations throughout the entire world. And so many of the alumni, the people who come from these programs, who go all the way through to top, they have ended up working and becoming some of the people at the beginnings of some of these companies that I list here. They don't just work at those companies, they are involved in the early stages of building some of the technological companies in US. But we want to bring this to the world too. And the way we do that is we invite the world to join. This is just a picture. It's a fun picture of something that has happened in our own training camps. which is once we get to the very top level, we actually even invite people from other countries to participate. In fact, the student here is from Australia. And so what we operate is we don't see this as only US centric. It's rather we want to help to bring and build an international collaboration. It's a huge pleasure to be able to talk to all of you because of the fact that we see the world as interconnected. And personally, I do, because I myself I'm an international. I consider myself a global citizen in the sense that I happen to live in the US. I was born in the US, but my parents are from Singapore, and I've traveled to many different countries, and I've enjoyed even visiting Yongjin Song's camp in Korea. I see all of this as a big international collaboration. And so our goal is to share these concepts, share these ideas, and hopefully some of them are useful. Well, maybe you can try. And who knows, maybe we will work together at some point in future. Thank you.
Thank you, Po-Shen, for very inspiring talk. I think, this is a very nice way to approach for the advanced student in mathematics. And I agree with you, it should be the pyramid structure rather than, selected structure. You need to have a good base in order to select, the top and the best student. Yeah. And then now we move to the third panelist, Dr. Han Kim Ho, to share about the Singapore experience, before we come in with the Q&A part.
Thank you. Can you show my slides?
Yeah. Can you see it now?
Yes. Okay. Good morning, everybody. Thank you very much. First of all, I would like to share with everybody that actually what Po-Shen just shared. Actually, I share with him his philosophy. So maybe perhaps from my perspective, I'll just share basically 3 slides. First, I think here I would like to share in Singapore. First of all, Singapore is a very small country. Our student population is very small, so we value the development of every student in our country. So, all right. So I will share this ecosystem that we have in Singapore. Yeah.
Single page view thôi. Và em có thể ngồi theo next thì mình kéo xuống trang sau thôi, sao? Làm đơn giản nhất có thể.
Yeah, okay. Right. So the first row, I just share with you actually our system, how we actually nurture mathematical talents. First of all, I would like to share my personal philosophy. To me, actually, in the world of maths and science, there's always a place for everyone. Therefore, we always believe that everyone can learn maths. Second, in our curriculum, I like to share that in our Singapore mathematics curriculum, there's been this focus on mathematical problem solving for all, from primary school all the way to the senior high school, which is our pre-university education. Now, on the top level first box, I'd like to share here that we actually started the gifted education program in a primary school. They were there for 3 years, and this will actually include those who are mathematically gifted. However, we have observed that over the years, not all mathematically gifted program students are admitted to the gifted education program. So today in all our primary school, they have introduced the high ability math program within all schools, and all teachers are trained. Now, at the secondary level, there's this emphasis on mathematical problem solving in our curriculum, as well as mathematical modeling, which I'll say a little bit more. And then in most schools today, they introduce enrichment program in math. Of course, this is optional. It's for students who are interested. And in many of these schools, this enrichment program will also include training students for our national maths competition. Now, to share with the audience here, besides the core mathematics subject, those students who are have a deeper interest and who have the ability can study an additional mathematics subject at the secondary 3 and 4 level. At the pre-university level, same. In recent years, we have upped the increase, the emphasis on math problem solving and mathematical modeling. And then for the students who want to do more, they can have an option to do further maths and a subject called H3 mathematics, which is a pure math subject that deals with doing deeper proofs. Now, I would like to also share that in many colleges, we have research programs in maths, right? For the students who are interested. So over here in our main curriculum, we are not teaching student maths just to do maths and do an exam, but also to actually use maths, right? Beyond in solving problems. So here I would like to share that here actually our focus is learn, do, and use maths. Now, the other part of ecosystem is outside school. So in Singapore, it's quite common to see many parents who want their children to learn more maths, to actually take part in private enrichment classes. Well, of course, the parents have to pay. But in terms of selection of talents, there are two main mathematics competition today in Singapore. One is the Singapore Primary School Math Olympiad, which is organized by one of our high school. We started in 1995 and then followed by National Mathematical Olympiad of Singapore, organized by the NUS High School of Maths and Science. These two competitions are used by secondary school to identify some of these mathematical talented. All right. Now, at the secondary level, I would like to also share that we have a different system. We have secondary school that provide 4-year or 5-year secondary education, and the junior colleges, which I'm the principal of one of them now, the 2-year pre-U education. But for many years now, we have introduced also the 6-year integrated program schools. Now we notice that we have the gifted program in a primary, but not the secondary. So it is replaced by the 6-year integrated program schools, as well as the 6-year diploma program at NUS High School of Math and Science. It's a specialized independent school. And actually, I was the one who helped set it up. I set up this high school and I was there from 2007 to 2015 as a principal. All right. So I will share a bit more if you would like to know, because in these 6 integrated program schools and the NUS High School, this is where the most of the top talented in math students actually join. Now, to support the maturing talent, we have the Singapore Mathematical Society, which is actually the Singapore's official representative to IMU. At the society, we actually organize the Singapore Maths Olympiads. At the lower secondary, the secondary 1 and 2, we have the junior competition. And then for those at the Sec 3, there's a senior competition. And then I would like to share that actually, we do not just focus on Maths Olympiads, because we know that when we get students to solve Math Olympiad problems, those are closed problems where the setters already solved the problems. But we also like students to explore maths and learn how to carry out mathematical investigation and possibly even attempt some of the open problems. So we have started to organize a Singapore Mathematics Project Festival since 2001. All right. Then at the higher level, we have the Singapore Mathematical Olympiads Open. Now, this is not only open to the senior high students, the JC students, but to everyone, even the secondary, right? And this open competition is the one that's used to identify the potential national team members, right, for training for the IMO. So, of course, previous national IMO participants still have to do well in this open to get a second chance to join the national team to represent Singapore. Now, I would like to share briefly at the Singapore Maths Olympiad. At the junior competition, a group of about 30 students who have done well, we selected for centralized training. Now, this centralized training is to provide students with additional knowledge, basically in areas of combinatorics, algebra, and geometry. All right, and then those who have done well will proceed to the senior training. Now, at the senior training, we also have students who have done well in the senior Olympiad, SMO senior to join in as well. So we have the Singapore Maths Society have a systematic approach to actually provide this centralized training to gear up the students for the IMO eventually. Why we have to do that? Because our entire main curriculum, if you just do the main curriculum, there are certain content which are not sufficient to prepare students for the IMO. And one area which I like to specifically highlight is basically the geometry and number theory. All right. Now here I would like to share that at the national ecosystem, we have the Singapore Science and Engineering Fair. This is where most secondary school students and the senior high students who have done research in maths can take part in this competition. I personally have been judging this competition for the last 3 years now. In fact, actually this year, for example, we have very good projects where students actually came up with modeling of the COVID-19 data and how to do predictions. All right, can I have the next slide? Yeah, just to share with you quickly, I talk about our maths focus. This is our Singapore Mathematics Framework. This is the latest. It's a pentagon, we call it a pentagon. It was first introduced in 1990, where the focus is on mathematical problem solving. And then there are a few components. One is conceptual understanding, the mathematical skills, the processes, which we focus a lot. And I think this is where the journey, the process of learning and doing maths is critical. And I think in this aspect, we are doing well. And then finally, the attitude. We believe that the final test of whether they have learned maths well is whether they learn to appreciate the value and the beauty of mathematics. And the last part is metacognition. This is something that the country is currently working on. This is the last frontier because as a whole nation, we are trying to get all students to be interested in mathematics, to be so motivated that they are more self-directed, they explore on their own. All right. And we hope that students who are good in maths are not motivated to learn maths because they want to win competition, but they have this intrinsic motivation because they enjoy doing maths. All right. So this is our current state. The next last slide. Okay. Just to share a few, from 2010, we have introduced the mathematical modeling process for schools to guide schools in actually bring mathematical modeling learning to students from secondary onwards. When I was in NUS High School, we started experimenting mathematical modeling in 2008, and it was pretty successful. All right, and hence this practice has now been extended to the entire country. So that's all I have. Thank you very much.
Yeah, so thank you, Dr. Han Kim Hong, for the presentation about the Singapore math education, and especially for the advanced student. The things that I like most about Singapore is very flexible. We have a lot of options for the student, but each option is very concrete and comprehensive. For example, we can see like for the NUS high school, right? They have a special 6 years program, and for Singapore, it's also starting from very early age for the advanced student in mathematics. So now we will move to the Q&A part, and we open for the question from the participant. So if you have any question for the three panelists, please put on the Q&A, or you can put on the chat. I will check through and ask directly to the panelists. But I would like to go and clarify some point from the presentation of the panelists. First, with the Yongjin, because you mentioned about the top level for the Korean student, how selective it is and so on. But I would like to ask, how early you start to identify the advanced student in Singapore, in Korea. You mentioned, for example, like the KMOs open for junior, right, lower middle school and high school, and it has an increasing trend for the early student to join the competition. Do you have any kind of system of the school for the primary student and for something like that? It's quite curious because we think that we have to start very early. Can you unmute yourself?
Yes, as I mentioned, we have about 27 centers for gifted. Actually, it's a science centers for the gifted students, usually for 6th, 7th grade students in 27 universities in the nation. So usually they are selected and educated for 1 or 2 years in their like 6th or 7th grade, and then through that centers we can easily find the best students. And then even in KMO in high school levels, there are like 6th or 7th grade students who get gold medals in high school levels. So we have a very good group of very young talented students.
Yeah, and the second question for you is, you mentioned in one of the slide a very important point, when the Department of Education, they try not to encourage the science and mathematics Olympiad because it's a lot of pressure for the study.
Yeah.
And the IMO medal has no advantage to entering the university. So is it this
Actually,
correct?
they have a strong disadvantage, because when their statement to propose in entering universities, they are not supposed to write down anything about Olympiad competitions. It's a ridiculous rule, you know. If she or she writes something about his, winning gold medals in KMO, then it is automatically dropped out of the competition in entering university. Is so ridiculous. But the basic problem starts from this one, and the education for mathematically or scientifically gifted students is a kind of a science and technology department of the government, and the Department of Education is concerning only the usual school education. So the two departments of the government are contradicting to each other in their policies.
I see. Yeah. Do you see the decreasing of the interest from the student when that policies come out? Because in Vietnam, around 2008, we had the same policy, no privilege for the student enrolling for the math competition when they entering the university. And we can see the drop of the interest for the student and the lower performance as well. So do you see anything like that?
Yeah, similar things. And for instance, for high school students, if they study hard on mathematics only, then they cannot enter the best universities. So they don't have enough time to study mathematics.
Yeah.
Outside of sports,
Yeah. Okay, thank you. So I will move to Po-Shen, because it's quite different, right? When we can compare to the way you select things. So the first question will be, what about the percentage of the IMO student to going for math degree at the higher education, and do they have any advantage when entering the university?
I think that we have seen that after we started teaching people more about advanced mathematics at the National Olympiad Training Camp, more people decided to move towards PhDs in mathematics and in theoretical computer science. These are related fields. The theoretical computer science is easier to get a job. But what we saw is, once we expose the kids from young that this is what research is, then maybe later they are willing to try it as well. And we see now there are some very successful people who have even published in Annals of Mathematics, I think, based on their work, even when they were undergraduate students or early graduate students. It's very impressive. Now, does this give advantage? Well, yes, it does. In the United States, the way that the university chooses the students is that the students say everything that they have done, and there is not any one exam. Now, the way that the university chooses students is they will want to have many people who are good at different things. I don't mean that there is the same set of things and everyone needs to be good at the same set of things. What I mean is there is this direction and the university wants good person in that. There's this direction, university wants a good person at that. This direction, university wants a good person at that. And so if you happen to be very good at mathematics, well, that's one direction. There's only one problem. The university doesn't want too many like that. So if you want to push yourself all the way and you really do very, very well, that will help you to get into MIT. But Harvard might not agree. Harvard might say, we already got our one guy, and that person is not even from US. Maybe they're from Korea. We got the best one done, right? And then after that, then the Harvard will say, and now I want to find somebody who might be president of the United States eventually, or something like this. So what I'm trying to say is, yes, it gives you advantage, but it's not guaranteed because maybe the university got enough of that person. However, we do have students write down that they did that. It's not what Professor Song said of not allowed to write. Our students are allowed to write, but they are expected to have whatever other things they can get to.
I see. Yeah, and I also see one of the points that Professor Chong mentioned in his presentation about the rule of the final candidates. If you have some of the female, right, one of them will be automatically selected. We discussed about it in Vietnam, but we cannot do it. I mean, in Vietnam, it's strictly only 2-day TST, and then if you are on the top 6, you go, otherwise no. So, Po-Shen, do you have any kind of the policy to encourage for the female students in general, not only for?
So we don't have that kind of policy like Professor Song had. Part of the reason is because it is difficult to define which groups to advantage. The United States is more complicated than Korea, even when you talk about things like ethnic background. I assume most people who live in Korea are Korean. United States is not that way. We have people from all different colors. And so it is too hard for us to say, this group you get special treatment, this group you do not get special treatment. In fact, when I became the coach, I made it a very strong formula, because before me, the coach had the power to make a change. I did not want to give myself that power because maybe I just like this student more than that student, and that is not fair. So I used my power to define a formula. Once the formula was defined, I said, I have no more involvement, and the rule is the rule. On the other hand, we do still want to encourage people from other backgrounds. So for example, when it comes to training students, we will invite female students to our training camp in large numbers. We will not just invite one, we will invite 10, maybe 12, so that we are building up a group of people who are all good at this particular kind of skill. So that level is not the same as being on an international math Olympiad team, but because it is about training, we can bring in people from different backgrounds. Universities in America do the same thing at a very wide scale across all these different ways to define what are the different diverse types of people. And that's just, that's the way we do it in America. So we will do that at the training level, but at the final competition level, it's just a formula.
I see. So can you tell a little bit more about the formulas? Because I mean, you didn't mention that in the presentation. Yeah, you know, Korea, right? I mean, Professor Chong mentioned select from five major competition. It is some weighted to get the final formula. So
yes. So the way we do this is that the International Mathematical Olympiad consists of problems where the answers are proofs. You have to write many words to explain. In the US, we do not have enough people to grade all of those proofs. So we have many rounds at the beginning where the answers are numbers, like 3-digit numbers. And finally, we have these last few people, they write the proofs, 500 people who write proofs. After that, we will pick down to about 30 people, and they will take, I think, 5 sets of proof questions. Yeah, five sets of proof questions over 1 year. And the formula is called add up all of the scores. Well, we do a little bit of change because one of the contests is called the APMO, which Professor Song told all of us is a good competition. We use it as part of our team selection process, but it has more questions than the other exams. So we multiply the APMO score by 3/5 because every other contest has 3 questions and APMO has 5 questions. That is the only difference. But effectively, our score is effectively just a sum. And that makes it so that there's no question of, is it fair or not?
Yeah, similar to Korea, we don't sum up all 5 scores by just summing. We just multiply by some weight in each exam scores. Yes.
I see. Yeah, thank you. Actually, in Vietnam, I mean, we only count for the final TST. So it means the student have to go through 2 days team selection test similar to the IMO, and that's done. We will select the top 6 from that. It's kind of different. Yeah. So we need to have a deep discussion about how we can improve the selection process and so on. Oh, Po-Shen, one more question before I move to Dr. Kim Han-ho. So how early, I mean, in the US, you can start having some kind of advanced program for the kids? Do you have any initiative for the primary student?
At the national level, the training camp is only for students who are in high school, which is age 14 and higher. That's because we are not very good at taking care of young people. Because they have to come from far. United States is a big country. They have to come from far and they have to live somewhere. We cannot be the father or the mother of a little kid. So that's why the national level only works from there. But because the US has so many different places where people are interested in mathematics, in each city, you might have small groups. Maybe it will be math circles because there are people who came from Eastern Europe or Russia or former Soviet Union who came to move to US, and they started programs to teach local children, elementary school, primary school children, math, because that is what they did in the former Soviet Union when they were growing up. And all of these are not under our control. These are independent. So we see that there are programs teaching kids in even primary school under 10 years old, but that is not our management. It is only because we have these big contests that people see they should start early, and because they want to, they push themselves up.
I see. Yeah, thank you. And Dr. Kim Han-ho, I have a question for you. So you say that, I mean, you are one of the people who established the NUS high school, and I know that is a very, very good high school for the student. And many students from that high school will go for the IO team from Singapore and going for further study math and science. So can you share a little bit about that? We have the same high school in Vietnam is attached to the university, and for each subject we have a class specialized in these subjects. But do you have the same thing in NUS high school?
Well, I'm no more the principal there, but I still remember.
Still, right?
Yeah. That's high school actually specialized in both maths and science, and because they are talented, they go beyond the normal school curriculum. So it's a very special school because it's the only school in Singapore where they did not sit for their national exams. Because when we know that students have to study for national exam and compete, that will take a lot of time. So instead, all our students will go through modules and then they will graduate with our own school diploma. Of course, we have to establish a reputation and a reliability, but we have succeeded, and this diploma now is very well recognized across the world. Using the diploma, we have students who have gone to Cambridge University, Oxford, MIT, and so on. So when they specialize, they go very deep into mathematics, physics, chemistry, and biology, and computing now. So these are the compulsory courses. They are compulsory courses in the first 4 years, and then in the final 2 years, they can go further specialization. So that's roughly what it's about. But one of the core keystone program is that all students are required to attend the 6-year innovation research course modules. And in the final 2 years, they're supposed to complete an advanced research project as a graduation requirement. So one of the outcomes which I've tracked over the years is that many of our talented mathematics students Like Po-Shen said, I think many of our Olympiad medal winners managed to get into top US university. And I also agree with Po-Shen. Most of them went to MIT. Not many succeeded in Harvard. But majority of the top talents who do mathematics have gone to Cambridge University. In 1 year, I think we had about 20 of them from a very small, but not all do mathematics. Many actually go branch into physics, chemistry, engineering. Today, I have lost count, but a number of them are doing a PhD in mathematics, particularly in California Institute of Technology, MIT, Harvard as well. So they still keep in touch with me. So I think in this aspect, we have succeeded. Although we are a small country, we do hope that we have some of our best who continue to commit their life to do mathematics, not to win competition, but to contribute to the mathematical knowledge and its use beyond, right, and help solve real world problems. I hope that's roughly what we had. So it's very successful because we find that they are not worried about national exams. And that school, until today, 100% of students will move on to universities across the world and also our local universities as well.
Yeah, thank you. Yeah, so another question for you. I mean, because Singapore have a very concrete and rigorous curriculum starting from very early age, and you also mentioned about the advanced program for primary students. In Vietnam, in 90s or something, we have a wide range system of the school for advanced students, even starting for the primary. And I think at the end of 2000 something, I mean, we stopped for the primary and the lower secondary advanced class and advanced school. And yeah, the same, in decreasing the quality of the math and science learning for the students as well. Can you tell us more about that?
Okay, maybe I can share a little bit on the advanced program. When we say advanced, we are not talking about acceleration in learning. The only acceleration that we have is at NUS High School of Maths and Science, because we know that they're able, so they will learn some advanced topics so that they can get access to some of the more challenging research work that they can do, especially in modeling. Across all our school, we focus on mathematical problem solving. So we focus on the process rather than the content. Because from the process, they actually will do things like generalizing, looking for patterns, using problem-solving heuristics. So if they have a certain content, the teachers in school will provide them a problem that is unseen, non-routine, where they don't have ready-made solutions. And then from there, they start figuring out. So in fact, actually, yesterday, Professor John Starr shared about mathematical flexibility. In our Singapore schools today, we are moving into mathematical flexibility. So when we do that, I think more students can access to this program. So we don't believe in accelerating in advanced topics early because not all students can handle, but we value more the learning process. And this has been introduced since 1990. We have come a long way and we have begun to see some of the positive outcomes. So today we don't need to stop Olympiad because nobody is crazy of doing Olympiads, right? But they know that the Olympiad is a means to an end and not an end to itself. Whether the students use Olympiad to have admission to university is up to them, because our university admission program today, besides looking at national exam results, they also look at interest and aptitude now through interviews. So the students can put in whatever of their experience, and then at the interview, they need to convince the interviewers to get into university. So I think that helps a lot. So I believe it works because we do not drive students to just do well in competition and then use the competition as a ticket to enter somewhere. So we have de-emphasized that. So I think we are fortunate. I think we for example, our national SMO, we are a small country, we still get a regular participation, about 8,000 to 10,000 participants every year, which is the interest is still maintained. At the primary level, there are about 5,000 students who take part in the national competition as well. Yeah.
Yeah. Yeah, I really like the point that you say. I mean, the Olympiad is not the end, right? I mean, it is just the goal for the student. And we have one question for you from the participants. They asked, I mean, he said that he's really impressed about the Jack Lim, one of the students from Singapore. I think he has five times at the IMO, 5 medals or something, gold medals. So he would like to ask about his success, because it's kind of the singular case in Singapore Olympiad. And where is him now? I think MIT.
Oh, okay. I'm still in touch with him because when he joined the school, I first met him. He's now doing his PhD in California Institute of Technology. I think he's, I just forgot his name, but he's doing combinatorics research. Okay. Well, he had 5 medals, 3 of which are gold, and in 2013, he had full marks. Now, the interesting about this boy is that he has to, when he solves maths problem, it helps him to release his stress. So maths is never stressful. When he's very stressed by other things, of course, he doesn't like to do language, he doesn't like to do humanity, he doesn't like to do biology. He's okay with chemistry, but he loves computing, physics, and mathematics. That's where his talent. So when I was with him, and I mentored him in his maths research project, and actually he completed a very nice solve a problem in graph theory with me. So I spent some time nurturing him. He's very natural, never wanting to win competition, always very driven by the interest. And occasionally in some of our local competition, in some tests, it's very interesting. He doesn't get full marks all the time. He loses out to his classmate. But when he doesn't solve a problem when everybody can solve, he just smile and strike his sword, and we find it very funny. So I think I like this because he's not entirely stressed when he can't solve his problem, right? He's quite natural. So I thought that is a very good example that I knew when he was a very young boy that he will go very far in his maths. And this is something that we hope all our talented mathematics students will go through. And today I know that many of them are like that. Because at NUS High School, I de-emphasize winning in competition. I always tell them, when you do a competition, it's a bonus. But the achievement is, the accomplishment is what you actually learn about the mathematics, what you discover. Do you find any beauty in whatever things that you learn? So I think that is the philosophy that we have emphasized. Yeah, and it works.
Yeah, thank you. Yeah, we have one question from a participant for Po-Shen. What is your opinion of this new in the New York Times? The New York mayors unveiled a plan to overhaul the gifted and talented education in the New York City. They want to reform, I mean, the gifted and the talented education in New York City elementary school. And it has been criticized a lot about widen the gap for the equities of the student. What do you think about that? And comment on this.
Wow, that is a very complicated political issue. So this is just one example of many things that have been happening across the United States in the last 2-3 years. United States used to have specialized schools for which you could take an exam and qualify into the school. And actually, those were schools which were producing some very, very strong students. But there were concerns that when you looked at the schools and you looked at the, as I said before, America is a country which has many different people from many different kinds of backgrounds. Politically, it became not so good that somehow if you looked at what the people looked like who all managed to qualify in for the schools, it did not represent the diversity of the United States of America. And at that point, that becomes politically difficult to support. And so unfortunately, those things then could not sustain their funding. My opinion is that I grew up in a state called Wisconsin, where there were no such schools in the first place. And as I pointed out before, there are many people who are very successful who came from places where those programs don't exist. It's true that if those programs were there, then it could have given some people a way to learn. But my way of approaching all of this is there's the internet, and the internet has no boundaries. And so actually, even things I work on is that I create online classes that are taken by thousands of students across the United States and across the world in the middle school range, late elementary, early middle school range. So the approach that we use now is if the local city will not support, well, You can use the internet to go and provide the same resources to people no matter where they are. And ultimately, the only thing that is limiting a person becomes whether they want to do it or not. That's actually why a lot of my work nowadays is running around the country, trying to convince more people that they want to do this. Once you decide you want to do this, there is a huge amount of opportunity on the internet, and you can get it. So I will just say that the realities of living in a country where there are people from many different backgrounds are such that when you decide how to spend the money, which is to help the whole public, considerations such as what are the people who are at that school become relevant. So my attitude is that is just reality, that is politics. And in the end of the day, if we want to create impact, we do it through internet.
I see. Yeah, I agree with you. There's no, limitation for the accessing to if you want to study. But one question is, do you have a system of the selective school in US and starting from which age? Because sometimes they have the advanced school from very early age in many countries.
Yes, so the ones that were the most famous in the United States were the ones that selected at the high school age, which means that they already finished the middle school, they already finished age 13, now they are 14, and they went and took some exam. And based on that exam, you found out who to bring together. There are relatively few special programs for younger children, in part because it's hard to tell at the very young age. Is it that the student is very special, or is it that the parents help the students prepare for that particular exam at such a young age that there's nothing complicated anyway?
Yeah. Okay. One question from the participants to all of the panelists. They would like to ask about how the Math Olympiad been funded in those countries. In Vietnam, it's all government funded. And there's nothing from the student. They don't have to pay the fee to entering for the competition and so on. It has some advantage, and we have a wide range of the selected school. Each province, we have one school, high school for the gifted student. And all of the students will be selected to that school. If you want to study advanced math, you need to enter into that school. You have the class for mathematics, and you go through that path. But it's different for other countries. I think Professor Yongjin mentioned about the funding from the government. It's I think 2,000, right? 200,000 from the government and 300,000 from the participant. But is it only for the KMO or only, and also for the trainings and the other business? Can we explain more? And then...
maybe I start.
Yes, the fund in total about $500,000 US is spent for like KMO and also summer camp, winter camp, and male educations, and all year long education programs too. But we have independent of this KMO programs, we have the government runs, as I said, 27 local regional centers for mathematically or scientifically gifted students, usually for like, as I mentioned, about 7th grade students. And we have 27 local centers, and then the fund is totally independent of our fund, of course. And also, as I mentioned, we have 28 science high schools, and we have 20 normal science high schools and 8 special science high schools. But science is, that is called the Science Academy. Science Academy has a little advantage comparing to a usual science high school, because they have better circumstances and better chances to enter universities, and also a little more flexible programs in curriculum like that.
Yeah. Thank you. Dr. Kim, I think you want to...
Okay, I think the only funding from the government or the Ministry of Education I can remember is pay for the registration of the participants and also the team leader and deputy team leaders. And then the government will provide up to a maximum of $10,000 per year for organizing of the Singapore Maths Olympiads and the various activity. Up to, because if we spend less, they give us less. That's all we have from the government. The rest of us, the trainers and myself, we are doing it as volunteers. So we spend our entire life contributing as volunteers. All these are on top of our work, including the professors who are doing the training. Yeah.
I see. Thank you. Yeah. What about US?
We have almost no funding from the government. In some years, I think it's near zero. And so the way that we run it is we have a fee when you take the competition at the very beginning, similar to what Professor Song said. At the very beginning, we might have 200,000 students take the exam, and they pay an average of $3 each to take the first round. Then you multiply the numbers and you have some money, but actually that's not enough because we have to mail, we mail the exams. Actually, $3 is almost just the cost of operating the postage and the grading, and that doesn't make much money. For all of the training camps, that is money that comes from donations. Actually, the model of American university system is teach students, hope that they become rich someday, and they give you more money back. And so that's how private universities work. And the way that we have raised our funding for the US Math Olympiad is somewhat similar. If you have the most amazing, most talented students in the entire country going through your program for many years, some of them will become very rich and some of them will become very powerful. Maybe they are parts of companies which are very rich and somehow they sponsor us in the end. Yeah. So my advice is actually, if you are teaching students and you are teaching them so that they are not only successful at the contest, but that they are successful in 20 years, some of them will be very successful and they will make it so that you can pay for everything.
It's a great point. And not only, I mean, contributing back for the financial support, but also, I mean, for the academic support as well, right? I mean, I think all of
yes.
Yeah.
Yes, those of us who have no money contribute by teaching.
By teaching, yeah.
So everyone can contribute something.
Yeah, I think Professor Chong also mentioned about you have around 20 assistants as a former IMO student, and Dr. Ho also mentioned about volunteering in teaching. We all contributing back to the system, and I'm a IMO medalist myself as well, and contributing back to the system. And I mean, the same. I mean, mostly kind of the volunteer things. Yeah. Oh, okay. So we are almost run out of time for the session. I have a question from the participants. It's very important. We talk about the training system, we talk about the school, we talk about the teacher and so on, but the parents are also very important. And you know, I mean, the parents are on two extremes. Some parents, they are very, they wish their kids to be very competitive and they start training the kids from very early. But now, I mean, more parents, they think math is not important, science is not important. I mean, I don't want my kids to go through that path. So the question is, I mean, how can you, as a very important person in the math and the science education in our country, if you give an advice to the parents, I mean, how can you encourage or persuade the parents to encourage their kids to study math and science? Yeah. I don't know who wants to go first.
Maybe I can start first.
Yes.
I think, first of all, maths and science is a compulsory subject for all students for at least 10 years in education. And of course, I think we do not want students to learn maths and science because they have to do it and sit for exams. So as a nation, we focus on the learning experience now a lot. As a nation, the government actually have put in funding, a lot of funding in the billions to promote research and development in STEM areas. So at the national level, in terms of job prospects and so on, there is a driving force to maintain this interest. So we can see this cascading down to schools, at least up to the senior high schools. But our challenge will be when they finish high schools, do everybody or every good student pursue a STEM degree and STEM journey? This is something that is still at work. But what I notice is that for our very talented, they still move on, like what Po-Shen say, the mathematics, they will all go to either mathematics or computing. They are almost certain to go that path. But we have very good response in the area of the physics, chemistry, and biological sciences. Our challenge will be getting more students into the engineering courses, right? Which we have depended on foreign talents coming in to support our economy. So this is our current state, but we are still working at it. Anyway, Singapore is a very small country. We still have to we have to spread the talent across many sectors. So overall, I think we are not quite short. Yeah, that's the current state of affairs in our country.
Yeah, thank you. Professor Jusson.
Yes. For parents, I mean, you mean, yeah. In my country, parents are getting more kind of liberal for their kids. So as long as their kids are good at for instance, music or sports and mathematics and whatever, usually parents are supporting their kids. And also in entering universities, like in about 20 or 30 years ago, parents are pushing their kids to enter like medical schools or law schools and things like that. But recently, parents are getting more and more liberal to their kids. And a very good point of our kids is that they are also studying mathematics or computer science after entering the universities, most of them, and not just the participants of IMO. Usually the participants of summer school and winter schools most of them are entering universities in math department, most of them. And we are accumulating those numbers and in our country, like in last 10 to 15 years. And then now we have very good young mathematicians in our universities. So we are hoping that this math education for talented students is related to getting more outstanding young mathematicians in the future. So we so actually about 20 years ago, when I first became the leader of our team, I suggested a new goal of Korean Math Olympiad. The goal is not just training and educating the talented students. We widened our goal to educate many students, like even in high schools and usually high schools and middle schools, for encouraging them to study mathematics like that. So, well, as I mentioned, we have a huge contradiction with math education department of the government, but still we are working hard.
Yeah, thank you. And what about Professor Po-Shen?
Yeah, I think this is really interesting that you bring up parents, because nowadays, most of my talks are for parents. Before, I used to give talks to students. I would visit high schools, I would visit middle schools, and I would talk to students. And then I realized that even if the students think differently after the talk, there is no point if they go home and the parent still has the same old approach of, but you should just prepare for the exam. Because actually, I love the thoughts that came from all of the other panelists. It's very useful to see mathematics as something that lets you think more creatively. It's flexible. I like that word that you used. So I'm trying to help convince parents that the value of mathematics is that you can learn how to invent. And actually, that's why I went on this tour. So I showed this picture of what I did for this summer. This was my summer vacation. There was an average of more than one talk per day. But if you look at the geographical distribution of where these are, this was everywhere. Now, why did I do this? I did this because when I gave Zoom talks, the parents would tell their kids, go watch this guy, and the parents would go away. Because the parents would say, your kid's job is to learn, parent doesn't do it. So that didn't work. And then I offered parent talks on Zoom. But when you do that, the parents weren't paying any attention because they just had the camera off and they didn't care. So then I said, that's the way to do it. You tell them the national coach of the Math Olympiad team is coming to their city. Oh, they bring the kid because they think the kid will get to learn some math tricks. But the parent is stuck there because they had to drive the kid there. Now, once they show up, I start giving a talk where the talk actually talks about what I work on now. In fact, the work I work on now, the research, is across both mathematics and health. And in fact, actually right before this talk, the talk I gave was to Caltech. It's funny you mentioned Caltech, where Jack Lim is. I was just giving a talk at Caltech. One of the audience members was a Nobel Prize winner, right? But the work that and she was working on chemical engineering. But the work that I do is using mathematics to think of new ways to fight disease. And when I give this talk, then the parents start to pay attention. And they say, what? Didn't know math could be useful. And I use this as a way to steer the parents to say, you know, it's okay that math can help you with exams, but there's much more useful thing, which is math can help you invent things. But I use the fact that I have the parents stuck, in an actual conversation, that's how you try to change the parents' attitude. So that's why I decided this is what to do. And I just give this as one example. But the important thing is, if you only talk to the student, it doesn't go home to the parent. And the recipe I have found, which can be done by anyone, is you give talks in person, and the parent has to be in the room because they drove the car or took the train to bring the kid there.
Okay, so thank you, Po-Shen. So I think the response from the three panelists, it's a great way for us to close this panel discussion. We have listened from very informative and insightful and also inspiring sharing from the three panelists. And we can see that the system in different countries are very different, but we already have a high values for the gifted student, advanced student. And the Olympiad is not the end. It doesn't start for them. And we preparing them for the high achievement at the high school, so they can have even higher achievement in the next 10 or 20 years for their future lives. So thank you again for all the three panelists to join us in this meeting. And right after this one, we will have the discussion about advanced math education in Vietnam from the three speakers. And I would like to invite you all to stay with us to listen from the Vietnamese experience if you have time. Okay, thank you very much again.
Thank you. Thank you, everybody.
Okay.